The next question is find V naught of S divided by Vi of S for the network shown. Assume gain of the buffer amplifier is 1. The first step will be step solution. Take Laplace transform of the network. So we will draw the S domain network. Okay. The S domain network will be as shown. Vi of S. So this becomes 1 by Cs. C value is 1 microfarad. So this becomes 1 divided by S into 1 into 10 to the power minus 6. And this is 1 mega ohms. This is 1 into 10 to the power 6 ohms into, the next part of the network is the buffer amplifier. Now the buffer amplifier is normally employed in order to provide electrical isolation to the network. So you have this circuit which is having a high power rating sometimes, and there can be the left side, the right side circuit will be of low power. So in this case, you need the output like it can be sensitive enough, so you need electrical isolation between them so that any damage for the first in the left side of the circuit will not damage the right side of the circuit. So in that case we go for buffer amplifier, and even in electronics part sometimes buffer amplifier is used for impedance transformation. So one of the application of buffer amplifier is to provide electrical isolation. Here we have capacitor, resistor, and this voltage is V naught of S. The value of the resistor is 1 into 10 to the power 6 ohms, and this capacitor it was 0.5 microfarad, so 1 by Cs, so S into 0.5 into 10 to the power minus 6. Now how do we actually solve this problem? Because we don't know the internal structure of the buffer amplifier. We don't know what is inside the buffer amplifier. So what we do here is that I take this voltage as Vi, not Vi, sorry, V1 of S, and this voltage, that is output of the buffer amplifier, I take it as V2 of S. So in the question it is given that the gain of the buffer amplifier is 1. So from the given data we can say that V2 of S by V1 of S is equal to 1. So in that case, now we will split this network into two parts. The first part will be, so first we will analyze only this part, and the second part is this part. This is the second part. So we will take these two networks separately, and then we will get Vi of S. We will find out V1 of S by Vi of S, and we will find out V0 of S by V2 of S. So if this is done, then we can find out, we know what is V2 of S by V1 of S. Then we can find out V0 of S by Vi of S. So with that in mind, first I will draw the first part of the network. First part of the network is as shown. This is the capacitor, capacitor, resistor, and this voltage. The voltage across the resistor is nothing but V1 of S, which is the input voltage to the buffer amplifier. Okay, and here we have Vi of S. This value is 1 divided by S into 1 into 10 to the power minus 6. Value of this resistor is 1 divided by, it is 1 into 10 to the power 6 ohms. Fine. So now we need to apply KVL. So when we apply KVL, this is my output and this voltage is my input. So I'll take current here as I of S. So applying KVL to this part network. So applying KVL, we will have Vi of S is equal to 1 by Cs into I of S. So 1 by S into 1 into 10 to the power minus 6 into I of S plus 1 into 10 to the power 6 I of S. So when I simplify this, so I can also write, by simplifying this equation, I get Vi of S is equal to 10 to the power 6 by S plus 10 to the power 6 into I of S. So I can write this as 10 to the power 6 plus S into 10 to the power 6 by S into I of S. This is my Vi of S. I'll take this as equation number 1. Next, we know that V0 of S is equal to I of S into 10 to the power 6. So I can write I of S is equal to V0 of S divided by 10 to the power 6. So I'll take it as equation 2. I'll substitute equation 2 in equation 1. So with that, I'll get Vi of S is equal to 10 to the power 6 plus S into 10 to the power 6 divided by S into I of S is equal to V0 of S by 10 to the power 6. So this 10 to the power 6, so now this 10 to the power 6 and these cancelled. So what remains is 1 plus S by S into V0 of S. So V0 of S by Vi of S will be equal to S divided by S plus 1. This is equation number 3. Sorry for the mistake here. This is not V0 of S, this is V1 of S. So this is not V0 of S, V1 of S. That is the input of the amplifier but output of this network. Okay, so I'll have V1 of S divided by Vi of S is equal to S divided by S plus 1. Next we will consider part 2 of the network. So part 2 of the network is capacitor. We have a resistor connected. So this voltage is V2 of S, where V2 of S is nothing but the output of the buffer amplifier. So this will act as input to this part 2 of the network. Okay, so this capacitor value is S into 0.5 into 10 to the power minus 6. This is equal to 2 into 10 to the power 6 by S. And this resistor will have 10 to the power 6 ohms value. Okay, so the current in this circuit, again I'll take it as I of S. So applying KVL, I get V2 of S is equal to 2 into, sorry, it is I of S into 2 into 10 to the power 6 divided by S plus 10 to the power 6. The V naught of S value is equal to I of S into 10 to the power. So I can write from this equation I of S is equal to sorry, V naught of S by 10 to the power 6. This is my equation number 5 and this is my equation number 4. Substitute equation 5 in, so I'll get V2 of S is equal to 2 into 10 to the power 6 by S plus 10 to the power 6 into I of S is nothing but V naught of S by 10 to the power 6. When you simplify this, what remains here is that 2 plus S by S into V naught of S. So V naught of S divided by V2 of S is equal to S divided by S plus 2. This is my equation number 6. So we know that V1 of S, sorry, the buffer amplifier gain, that is V2 of S by V1 of S is equal to 1, which means V2 of S is equal to V1 of S. With that, I can write from the first one, from equation number 3, that is this equation, V1 of S is equal to V1 of S is equal to S divided by S plus 1 into Vi of S. Then from equation 6 I can write V2 of S is equal to S plus 2 by S into V naught of S. This is equation 7 and this is equation 8. Since these two were, and this is equation 6a. So from equation 6a, I can equate equation 7 and equation 8. So when I do that, I get S divided by S plus 1 V1 of S is equal to S plus 2 by S into V naught of S. So V naught of S by V1 of S is equal to, when you resimplify this, you will get S square by S plus 1 into S plus 2. This is the transfer function of the network. Thank you.